Hello students. So this is pandey. என்னோட பெரிய கனவு என்னன்னா இந்த நீட்ல ஐஐடில நம்ம தமிழ்நாட்டு ஸ்டூடெண்ட்ஸ் நிறைய பேர் உள்ள போகணும். ஆனா அதுக்கான கோச்சிங் ஃபீஸ் நீங்க பாத்தீங்கன்னா 1 lakh இருக்கு, 3 lakh இருக்கு. எனக்கு ஏனே புரியல அவ்வளவு இருக்கு. அண்ட் தோஸ் ஹூ ஆர் டேக்கிங் த கிளாஸஸ் அதுல ரொம்ப இன்ஸ்பிரேஷனா கியூரியஸா இருக்கிற டீச்சர்ஸை பாக்குறது ரொம்ப கஷ்டமாவும் இருக்கு. ஸோ என்னோட இன்ஸ்பிரேஷன்ல இந்த இந்தியாவில் ஒருத்தர் வேற லெவல்ல செஞ்சுட்டு இருக்காரு. இட் இஸ் நத்திங் பட் ஐ திங்க் எவ்ரி ஒன் நோ அபவுட் ஹிம். தமிழ்நாட்டில் நம்ம அவரை பத்தி எத்தனை பேர் பேசுறாங்கன்னு எனக்கு தெரியல. பிசிக்ஸ் வாலா, ஜஸ்ட் none other than பிசிக்ஸ் வாலா. கரெக்ட். ஒரு இஸ் அ கேம் சேஞ்சர். கோட்டா இன்ஸ்டியூட்லயும் இஸ் கோயிங் பிகஸ்ட் கேம் பிளே ஆக்சுவல். ஸோ மிஸ்டர் டீச்சர் Alakh pandey sir. So it's very curious to take a classes and give some teaching proposal to you. And I am going to the channel start பண்ற main aim is also same actually. So my channel name is physics karan. Okay, so you are making YouTube channel like rickshaw wala, physics wala. In that way, no, I am going to start the channel like rickshaw karan, cinema karan, panakaran. That way I am going to start a new channel which is called a physics karan. Okay, and unfortunately, not unfortunately, fortunately, unexpectedly, my first video in this physics karan is for you. Okay, Alakh pandey sir, this is for you, and this class is ultimately to give the proposal of my teaching, and I'm very happy to take the class for. Okay, so my dear students, so my aim is to take a classes with the Tamil and English, but as I already told you, this is a this teaching proposal to my dream boy in India. So I am going to be take this class for English. At the meanwhile time, we will definitely take a classes in Tamil and English. And I will tell you, the aim of this physics current is ultimately to give the quality physics content, especially for those NEET students and JEE students. Okay, this is completely free and you can watch this, you can enjoy it. Okay, stay tuned. And today we will going to discuss the most interesting topic ever in 12th standard, which is the Maxwell equation. Okay, Maxwell equation. Okay, I want to give you one thing, one idea of what is the idea of Maxwell. You know, Maxwell is a very interesting guy, I think, because whatever he think, the base idea is symmetry. Okay, the base idea is symmetry. Okay, what is symmetry? What he thought initially, he want to think about symmetry in nature. Symmetry in okay, just a minute. Symmetry in nature. Okay, symmetry in nature. Adenna symmetry in nature. What is the meaning of that? And I will tell you this. Just a very crazy idea. Okay, Faraday. Everyone knows about this Faraday equation. Pandey sir, this is for you. Faraday equation, no? Faraday equation. Everyone know about this Faraday equations. What is Faraday equations? This flux equal to minus of d phi b by dt. Of course, we know the formula, but what is the meaning of this? The meaning is change in flux. Okay, change in flux with the time, right? Change in flux with the time. Change in flux with time. What is this? We call it as a EMF. But we already know one thing. This potential V is equal to ED. Yes or no? We already know about this. This potential V is equal to ED. So I can write this epsilon as E into some DL value, electric field, which means this electric field. See, whenever I think, what is the flux? This is the magnetic flux, no? See, this is the idea. This is a base idea, a very interesting idea. Whenever there is a change in magnetic flux, that going to be in there is a induced electric field is there. Think about this is how nature works now. So crazy. Whenever there is a change in magnetic flux, an EMF, one EMF is induced. But I can say in this way: whenever there is change in magnetic field, there is an induced electric field. Yeah, that is what we are going to learn right now. This is a very crazy idea, and that is what you have to think also, right? That is also you have to think. So let I will give about this a little bit. What to Maxwell, what to Maxwell symmetry idea is. This is symmetry idea is see closed integral of E vector dot dl vector. This is actually Faraday equation. This is actually Faraday equation. A rate of change of magnetic flux. Of course, this was happened in opposite, so we put some negative sign. We put negative sign. What is the meaning of this? What is the meaning of this? Let us. I call it as induced electric field. I call it as induced electric field. When it is induced, when there is a change in magnetic flux, rate of change of magnetic flux, we can call it as in that way with respect to time, or we can simply call it as rate of change of magnetic flux. We can simply call it as rate of change of magnetic flux, no problem. So this is actually a Faraday equation. No, this idea is Maxwell gave this idea, but this formula is basis came from Faraday only. This is nothing but epsilon only, right? So epsilon equal to minus d phi b by dt. So this is a Faraday equation, no problem. Now Maxwell asked one question from this. What is the question he asked? What is the question? That is a very interesting. That is why I'm telling you Maxwell is so crazy. You think about this crazy symmetry matter. Whenever there is a change in magnetic flux with respect to time, there is an induced electric field. Whenever there is a change in magnetic field, I can say it's a magnetic field also, because flux, what is the idea? What is the formula for flux? What is the formula for flux is equal to VA into cos theta. Oh, which is magnetic flux. I can call it as magnetic field. Okay. So whenever there is a change in magnetic field, there is an induced electric field. Appa question திருப்பி போடு. Reverse the question. You comes to understand the idea of Maxwell. What is the idea, man? What is the idea of this Maxwell? What is the reverse the question? If there is an induced or not induced, if there is a change in electric field, okay, if there is any change in electric field, okay, is magnetic field is induced or not, that is the question, man. Do you understand the question now? You know how this Maxwell thought. Faraday gave the equation, and Faraday, with the help of this Faraday equation, Maxwell trying to figure it out. If there is a change in magnetic flux, there is any change is there is a induced electric field is there. Reverse the question. If I change okay, if I change the electric field, is there any possibility of induced magnetic field is there? Possibility of induced magnetic field is there or not? The answer is so crazy and interesting. The answer is Answer is yes. Yes. You know how? You know how? So how nature works? How nature works? Nature works like how nature works. This was given by Maxwell actually. Okay. If any change in electric field with the time, with the time results cause it caused induced magnetic field B vector. Okay. So this is the first one. Second one, if there is any change in B vector with the time, with the time results what cause it cause induced E vector. Aha, this is a very interesting, this is a very interesting thing, how nature works. That is what you have to think, how nature works. No, this is how nature works, because we never ever thought that nature works in this so beautifully. No, we never thought that nature works in this so beautiful way, so that we can found how nature is so crazy, how nature is so crazy, no, how nature is so crazy. That is what Maxwell gave. And from this idea Maxwell figured it out, and Maxwell tried to think about the one more point of view. Okay. Okay, when electric field is over the length, electric field is over the length, that is nothing but EMF, that is nothing but a voltage. And he have four different cases. With that four different ideas, Maxwell gave four elegant equations. Four elegant equations, man. It's very interesting, four elegant equations, and that is what we are going to discuss right now. Four elegant equations of Maxwell. I am going to teach you integral form of. We are not going for differential form in a higher secondary level. Okay, I will tell you the integral form. So that I will teach you integral form. Okay, integral form of Maxwell equation. Integral form of Maxwell equations. So this integral form of Maxwell equation, no? This integral form of Maxwell equations, we have first idea is nothing but Gauss law. Gauss law for, this is for electrostatics. Electrostatics, from the idea of Gauss law of electrostatics, Maxwell gave one conclusion, man. This is a formula of Gauss law only, but Maxwell gave the very interesting conclusion. Whenever there is an electric flux, what is electric flux? Closed integral of E vector dot dA vector equal to Q enclosed by epsilon naught. What is the meaning of this? See, think about the situation. Okay, what is a flux first of all? What is a flux? Number of electric field lines crossing the area. Correct? Crossing the area, given area. Okay, normally, actually perpendicular crossing, whatever it is, crossing a given area, let's say. So, which means we have some value. Here we have some value, positive or negative, we have some value is there. Here we have some sort of value is there. Some, it's not zero. It's not zero. We have some sort of value is there. So, if you have any something sphere is there. So inside there is some positive charge is there. Definitely electric field is crossing the particular surface of area A, and this is E vector crossing the particular area A. E vector is there, and there is a number of field lines is also crossing. No, there is some number of field lines is also crossing, which means it's a positive value. Or if you have some negative charge in the sphere, negative charge in the sphere, electric field is going into it. Electric field is going into it, which is E vector. This is positive, this is negative. So we have some negative value here. We have some negative value. So which means what? Within the sphere, we have some specific charges. We call it as a monocharge. So it is possible, it is possible that we can kept a single monopole of charge in the sphere, in the sphere. So what is the conclusion? So electric monopole exists in universe. Okay, so electric monopole is exist in universe. Electric monopole is exist in universe. This is a very interesting idea that there is a positive charge, there is a positive charge or a negative charge. There is a positive charge or negative charge separately, they are available in the universe. So this is one first idea which was given by Maxwell. So second idea which is actually Gauss law only, but it is given by Maxwell. Okay, it is given by Maxwell. So Gauss law of magnetism. Gauss law of magnetism. Okay, what is the Gauss law of magnetism is when the magnetic flux B vector dot dA vector is equal to, guess what? You have a positive value. If you have a positive value, one positive pole is there. I mean, north pole is there. If you have negative value, a single negative pole is there. The answer is Shunya, zero, zero, which means what? Which means what? This is a closed integral. This is a net value. The net value of B vector dot dA vector. Net value means total value. The total value is zero, which means what? If you take any, north pole and south pole, if you take any, any area, something like this. Okay, some particular area is there. What happens? Magnetic field from here to here. Magnetic field from here to here is traveling north to south. North to south is traveling. The point is, in this area, it is coming towards the area, and here it is coming away from the area. If you add this coming towards the area, this is away from the area. So if you add the net value, the net value of this flux tends to zero, man. Net value of flux tends to zero. Okay, you understand this point? If you not understand, I will tell you one more thing also. Okay, so you have, we have something called, let I have some different color so that you will understand much more. We have some magnet is there. Okay, north pole and south pole is there. So what happens here? We have some particular closed integral is there. Okay, the question is, what is the value of net flux? What is the value of net flux? That is a question. So what do you think, man? What do you think? See, listen. This is the area, no? This is the area A. So the magnetic field is traveling in this way, right? Magnetic field is traveling in this way. No magnetic field is crossing each other. Remember that. No magnetic field is crossing each other. Okay, so it is something like this. So what you can find is, see, this is the area. Okay, something was happened there. Okay. Okay, fine. So this is the area. What happens here? So this is electric field is going out. Electric field is, magnetic field is going out. This is magnetic field out. This is magnetic field in. So if I add a net magnetic field value V out, okay, minus V in, and both are equal, magnitudely both are equal, and it becomes 0. So this idea, very interestingly explained as no magnetic monopole exists in universe. No magnetic monopole exists in universe. Okay, this is what explained by Maxwell. Okay, this is what explained by Maxwell. I think something was happened. Okay, so this is what I explained by Maxwell. Okay, now next, the third equation. We are going to discuss the third equation. Third equation, that is also very interesting equation. Third equation is also very interesting equation. I will tell you why it is so interesting. Third equation is also interesting. Third equation is nothing but Faraday equation. Faraday is always interesting, Faraday equation. This is a Maxwell third equation. Okay, Faraday equation. Don't worry, I will give you the conclusion. Don't worry, I will give you again. What is a Faraday equation? Epsilon equal to minus d phi b by dt. The rate of, which is, what is mean by epsilon? The net induced EMF. Okay, this is induced EMF equal to rate of change of magnetic field. That's it, man. Correct. And what is epsilon? We know that V is equal to ED. Remember this formula? D is nothing but distance. Okay. For integral, we can written as integral of E dot dl vector. E vector dot dl vector. And that is equal to, this is over the length. Okay, over the length. So minus d phi b by dt. Okay. So this is the Maxwell third equation. Okay, this is Maxwell third equation. This is Maxwell third equation. Okay, this is Maxwell third equation. The fourth equation, which is a Maxwell, because Maxwell also involved Maxwell Ampere circuital law. What is the meaning of this? See, here we very clearly define electric field over the length is nothing but a rate of change of magnetic flux. In the similar way, magnetic field over the length. So magnetic field over the length. Definitely that is also going to rate of change of electric field only. But how it is happening, I will tell you that. This is nothing but, this is equal to, do you remember this? Mu naught is equal to conduction current plus displacement current, which is given by Maxwell only. Okay, this is nothing but Maxwell displacement current. Generally, we are not using Maxwell and all, just written as a displacement current. Displacement current. Okay, this is displacement current. What is displacement current? Displacement current is nothing but epsilon naught times of rate of change of electric flux. What is electric flux value? Closed integral of E vector dot dA vector. Yes or no? E vector dot dA vector. So from this we conclude this magnetic field over the length dl, which is nothing but mu naught times of conduction current. Conduction current over any wire. Okay, conduction current over wire or any wire plus. See, you have to multiply this mu meter over here also, no? So mu naught times of displacement current. What is the value of displacement current? Please tell me. What is the value of displacement current? Epsilon naught times of rate of change of electric flux. Rate of change of electric flux. Oh ho ho. What is rate of change of electric flux? We already know about this. So which is mu naught times of IC plus mu naught times of into epsilon naught times into d by dt, which is nothing but v vector dot dl vector, right? Of closed integral of E vector dot dA vector. This is the integral form. This is the integral form of Maxwell Ampere circuital law. This is the integral form of Maxwell Ampere circuital law. So, sir, then what is the meaning of this equation? Then what is the meaning of this equation? The value of magnetic field over any length is nothing but mu naught times of conduction current, mu naught times of conduction current into current due to or electric field due to change in magnetic field due to change in E vector with the time. With the time. Okay. So these are some basic fundamental idea. I am going to give you the overall equation of conclusion. Conclusion of Maxwell. So what is takeaway of Maxwell? Takeaway from Maxwell. Take away from Maxwell equation. So we can explain different ways in ways also. For in a differential form, no, we can explain a very so interesting way also. So that I will tell you. So first, please note these things. So first, Maxwell, or I will put a star mark here. Maxwell first equation. Maxwell first equation. What is Maxwell first equation? Which is Gauss law equation only. So closed integral of E vector dot dA vector equal to, there is a enclosed charge by epsilon naught. So what is the understanding from this? Okay, electric monopole exist in universe. So you can split the charge bar. So you can take a charge like a positive charge, negative charge. You can able to split. You can split into two equal. You can in your hold. You can able to hold. I'm not. I'm telling hypothetically, but I'm just telling you for our understanding. You can able to hold a single positive charge. There is a availability of single positive charge or a single negative charge in the universe. What is second equation? What is second equation? Second equation is magnetic field over the area, which is magnetic flux, equal to 0, which means no magnetic monopole exists. Sir, what you are saying, sir? Yes, man. There is no magnetic monopole. So some intelligent students may thought, sir, there is a bar magnet is there, north pole and south pole. I split it into two parts. So I have one part is north pole, another part is south pole. No, you may think that way. But after you split, this is north, this is south. This will not be a north pole magnet, south pole magnet. Automatically, the another part becomes south, another part become north, man. So you cannot able to split. You cannot able to find a single north pole or single south pole in the universe itself. So north pole and south pole always like a couple, man. I think they married and not get any divorced. No, they get married and not get any divorced. You know what happens with positive negative charge? Maybe they will get a divorce and all, and they will be separated. But this north pole and south pole, they will not separate. So there is no magnetic monopole exist. If any of my students, if you prove, if you find somehow the availability of a monopole in the universe, ultimately I'm telling you, you will get a Nobel Prize, man. Okay, Nobel Prize. Don't worry. So you will get a Nobel Prize if you find what is the okay. I erase this. We don't need this. We don't need this. Correct. We don't need this. What is the third equation? What is the third equation? These are all first equation, second equation. What is the third equation? Okay. What is the third equation? Third equation is nothing but Faraday equation. Okay. So electric field over the length. Electric field over the length is nothing but rate of change of magnetic flux. When magnetic field is changing, electric field is induced. Okay. Magnetic field is changing, electric field is induced. So this is induced electric field, induced E vector, electric field. எதனால 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 ஏற்படுது? Why? caused by change in B vector, rate of change. Maybe I will write as rate of change of B vector, which is crazy, which is a nice idea actually. Okay, rate of, because rate is time only. Okay, rate of change of B vector, rate of change of B vector. So what is the fourth equation? Fourth Maxwell fourth equation. If there is any magnetic field over the length, is nothing but mu naught naught times of conduction current, mu naught into conduction current plus mu naught into epsilon naught of rate of change of electric flux. Okay, we can write this electric flux in way of in this way, E vector dot dl vector also, but for your understanding I am writing in this way. So we have four different equations, no? We have Maxwell, no? Maxwell, yeah, we have four different equations, which is literally a very interesting equations. Okay, these are all Maxwell. These are all Maxwell. Maxwell gave the gift to this universe. No, not us actually. Okay, Maxwell gave a gift to us, and these are all this Maxwell. These are all this Maxwell equations. Okay, so we have four different equations, the four different ideas. So I complete my class from this. So tomorrow, I mean the next class, we will come with, I'm coming with some one more crazy ideas. So stay tuned, stay happy. So learn physics in a nice way. Okay, so physics is always a hero because we are a physics current. We have to think in that way. Have a physics gives you happiness. Okay, I want to tell you this. Physics gives you the happiness, and you have to find it, and definitely you will crack this NEET or JEE, whatever, which is a very easy only. Okay, if you have a curiosity and if you have a problem solving skills and all. Okay, thank you so much. Thank you so much.